All right, guys, welcome back. And in this video, we're going to talk about angular speed and linear speed. Um, so here's a definition. As a point moves along a circle of radius r, its angular speed w is the angular rotation theta per unit time t. So basically, if you have a circle rotating, let's say it's a wheel or something, so angular speed is how fast the rotation happens. Okay, it's not about the distance, it's about spinning around a center point. Now, linear speed, on the other hand, is denoted by v of the point can be found as the distance traveled or the arc length per unit time t. So the difference is now we're fixated on the point that's on the circumference of the circle, and we're looking at how fast it's moving, how much distance it covers. In a certain time t. So here we're looking at how much angle is changing. And here we're actually talking about the distance covered. All right. And the last formula for this section is angular speed and linear distance, how they're related. So this is the formula that gives the relationship between them. So the distance covered equals the radius times the angular speed. Okay. So let's apply this. Here's an example. It says a water wheel completes one rotation every 5 seconds. Find the angular speed in radians per second. Well, that's easy. So the angular speed W is theta divided by t. Well, it says one rotation every 5 seconds. So one rotation is 2 pi over 5 seconds. So that's your angular speed, 2 pi over 5 seconds. Or, well, if we were actually to simplify 2/5, and we could write it as a decimal, I guess, that would be 0.4. So 4 over 10.4 times 5 pi per second. Okay, so that's it for this problem. Now it's your turn. It says an old vinyl record is played on a turntable, rotating clockwise at the rate of 45 rotations per minute. Find the angular speed in radians per second. So one thing that you will have to do is once you find your angular speed, so it's going to be in radians per minute, you have to convert them minutes into seconds. So that's a little bit, yeah, a little bit more work. But we're going to actually do this for the next problem, I believe. All right, so please try it. All right, so the next, so I hope you got that problem right. If not, let me know. We could do it together. Next example, find the linear speed. A bicycle has wheels 28 inches in diameter. A tachometer determines the wheels are rotating at 180 revolutions per minute. Find the speed the bicycle is traveling down the road. Okay, so let's write down what we have. Well, so first of all, we have the diameter of the wheel is 28 inches, and that's a diameter. But in all of the formulas, I'm going to remind you, we have radius. So to find the radius is actually half of a diameter, if you don't remember. So for the radius, we have 1/2 of 28 inches. So that will give us a radius of 14 inches. Okay. What else do we have? Wheels are rotating at 180 revolutions per minute. So that's our angular speed, right? So 180 revolutions. So one revolution is actually 2 pi, and we have 180 of them per 1 minute. Okay, so that's our angular speed. We need to find the speed of the bicycle traveling down the road. So the formula that relates our linear speed v and the angular speed is this, r times w. Okay, so we know that r is 14 inch, and then we have 180 times 2 pi, so 360 pi divided by 1 minute. Okay, let's put it in the calculator. 14 times 360 gives us 5,040 pi divided inches, right? We have inches in the numerator, and then 1 minute in the denominator. Okay, so but they want us to find the speed. Did they tell us? Well, they didn't tell us which units they want, but it would be more convenient actually to convert it to the more the units that we're used to, and we're used to in miles per hour, right? So that's the speed that we usually communicate, the units that we communicate speed in. So let's go ahead and convert, but first we need to figure out how many inches in a mile. Well, with minutes and hours, we know that 1 hour equals 60 minutes, right? So we can use this first to convert. So I'm going to multiply by unity fraction. Again, decide which one goes in the numerator and which one goes in the denominator. I would argue that 60 minutes will go into the numerator because we want to cancel out minutes, right? And then an hour will go down. Okay, so we're increasing this number even more. So multiplied by 60. That's giving me 302,400. So 302,400 pi inches over in 1 hour, right? All right, we still need to convert inches into miles, and we could do inches to feet, feet to yards, yards to miles. We could do all that, but I'm gonna actually Google how many inches are in the mile. So hang on. And the Google said that 1 mile is actually 63,360 inches. So I'm going to use that as a unity fraction. So I'm going to put inches on the bottom this time. 63,360 inches. And on the top, I have 302, 400 pi inches. So again, inches and inches cancel, and I put the rest in the calculator. So I already have 302,400. I'm going to divide it by 63,360. And I have, look, this is already better. About 4.77 miles per hour. Okay, so about 5 miles per hour. All right, guys, so this is how we solved this problem. Now the one that I want you to try is this one. It says a satellite is rotating around Earth at 0.25 radian per hour at an altitude of 242 kilometers above Earth. If the radius of Earth is 6,378 kilometers, find the linear speed of the satellite in kilometers per hour. So, okay, again, I want you to pause the video, try this problem, let me know if anything goes wrong. And I'll see you in the next video. This is the end of section 7.1.